Welcome. We are on the last page of our Chapter 5 exam practice. And before I jump in, I just wanted to remind you here at the top that as we're looking at binomial probabilities, we'll need X, which represents the number of successes in n trials of a binomial experiment. And when we perform a trial, it can either be a success or a failure. So the probability of a success on a trial, we do lowercase p, and probability of failure on a trial, we indicate with lowercase q. And then I've given a table here to help you remember the syntax for finding various probabilities based on whether the question is X, the number of successes is exactly a number, or these other four cases of inequalities. So you're welcome to refer to that, but I will just jump in here now at number 7. All right, so we have a multiple choice test consists of 12 questions, each with 5 possible choices, A, B, C, D, E, one of which is correct. A student decides to randomly guess on each question, making this a binomial experiment. So let me identify these variables before we keep going. So N, the number of trials, the student's going to have to guess 12 times, so 12 trials, so 12 questions. And then on each trial, on each question, the probability of a success, so getting it correct, well, we've got 1 that's correct out of 5 choices. So there's a 1 out of 5 chance of getting the question correct. And that would mean Q, the probability of failure. If one of them is right, then the other 4 would be wrong answers. So 4 out of 5. And we could work in decimal as well. So 1 divided by 5 would be 0.2. And then Q, 4 divided by 5 will be 0.8. All right, so remember P and Q are complements. So if you add the P to the Q, 0.2 plus 0.8, we have to get 1. All right, so we're all good there. And then let's do the probability. So they'd like to know for B, what is the probability that a student answers exactly 6 questions correctly? So the exact case, exactly 6 would be equal 6. So we want the probability that X, so remember that's our random variable X, the number of successes is exactly 6. All right, so in the exact case, we use binomial PDF, and then that table that I showed you indicates the third value as K. So if you do use the table in the question, exactly 6, that means the value K is equal to 6. So the value of K there is 6. And they say the syntax is binomial PDF NPK. All right, so let's go ahead and get that. So binomial PDF, N is 12, P 0.2, and then our value of K is 6. All right, so I'm going to go to my distributions, and I'm just going to scroll to binomial PDF, and then 12, comma 0.2, comma 6. All right, and it says to round to 3 decimal places, so we'll do that. That should be 0.016. And we'll stay in decimal since those were the directions. But just to speak it, that's 1.6%. So there's a 1.6% chance they would answer 6 out of those 12 correctly. All right, so for 8, I kept it similar. We still have 12 question multiple choice, but this time each question has 4 possible choices, one of which is correct. So what will change here is your chances of getting a question right, instead of being 1 out of 5, will now be 1 out of 4. And again, a student will guess on each question. So N, still 12 trials. P, the probability of a successful guess, 1 out of 4. And I'm going to write that in decimal now, 0.25. Just to remind you here that to find Q, it's the rule of complements. So Q is always 1 minus P. So probability of a failure Q is 1 minus the probability of a success. And that will be 0.75. Okay, so we don't need the Q for the probability, but I'll return to Q in a bit. So just reviewing there, then we can go to the probability. So the probability that the student answers again exactly 6 questions correct. So same syntax as before. So we've got our N, we've got our P that changes though. So we've got our N, and then our P is 0.25. And then again, we're doing exactly 6. Okay, and then you can type that one in. I'm just going to write answers now. That one will be 0.040. And again, if you want to think percents, that would be 4.0%. So getting 6 questions correct, the probability there goes up because we have a bigger chance of being correct when there's only 4 choices. All right, done with multiple choice. Let's go to our employees at a company. So a study found that 70% of employees at a company commute by car. They take a random sample of 8 employees, and X will be the number of them who commute by car. All right, so N, the number of trials, they're going to check in with 8 employees at random. P, the probability they commute by car is given, 70%. So we'll get that in decimal 0.7. Q would be 1 minus P, the complement of P. So 1 minus 0.7, and that will be 0.3. All right, so always good to check. P plus Q needs to equal 1. In percents, 70% commute by car, 0.3 would be 30%. So in percents, P plus Q would be 100%. All right, so now we're going to find the mean variance and standard deviation of the distribution. All right, so we're looking at population mean, and X as a subscript just indicates our random variable X, the number of employees who commute by car. All right, so the mean for binomial distribution is found by just multiplying N times P. So we just take 8, multiply it by 0.7, and that'll give us an average of 5.6 employees. So I'm not going to write the units here. I just want to talk about what we're actually finding is if we ask 8 employees, do you commute by car, and we record that number, maybe none of the 8 commute by car. Maybe just 1 does, or maybe 2 do. It's possible also that you ask 8 people and all 8 employees do. So this mean is representing if you took these 8 employees and then another sample of 8 employees and another sample of 8 employees, and you continue to do that, what we would find is that on average, it would average out to 5.6 in 8 employees. So the answer for an individual value of X cannot be decimal. These are employees, but again, it represents an average. So 5.6 employees is good. All right. Let's do variance of the population. So variance is sigma squared. The X again just indicates the random variable. So this is our symbol for population variance. And to find it for binomial distribution, the formula is just NPQ. So we had our N was 8, our P was 0.7, and now we multiply that by Q 0.3. All right, so 8 times 0.7 times 0.3, and that is 1.68. All right, we don't work with variance often. We are typically going to spend our time measuring variation with standard deviation. So sigma population, standard deviation. All right, so standard deviation will always be the square root of whatever we get for our variance. So all we have to do is take the square root of the last answer, our variance, sigma squared, that we just found. And that, so on our calculator, square root 1.68. And now we do have to round to our 3 places as needed. So 1.296. All right, so without working with graphs right now, it's hard to really conceptualize what standard deviation there is telling us. But just as a reminder, it's a measure of spread from the mean. So if you ask 8 employees, on average, we expect 5.6 to commute by car. But that does not mean that the answer will always be 5.6. So standard deviation is not 0. It's a positive number indicating that there will be variation when you talk to every different group of 8 employees. All right, general concept there, and then let's continue. So we'll switch now to probability. So number 1, find the probability that less than 5 employees commute by car. So I'm just going to write my less than sign. Less than 5 employees commute by car. All right, so these are my possible values of X. So less than 5 employees might mean that none of them commute by car, or maybe 1 out of the 8 commutes by car, or maybe 2 out of the 8. We're going to keep going until we get to our biggest value. There would be 4, because we want the successes to be smaller than 5. So basically, I'm going to have the calculator add these individual probabilities for me, and that's the binomial CDF function. All right, so let me start with the question. Probability that X, the variable for number of successes, less than 5. All right, so binomial CDF for cumulative density function. So cumulative, we'll start adding these probabilities. So if we start at no successes and continue up, we'll just need to tell the calculator that we want to end the accumulation at 4. So we want N first, so that was 8. There's our N. And then P was 0.7. Now the third value I know is going to be 4, because that's where I want the accumulation to end. But if you like the table that I showed above, it uses K to represent this value 5. So in the case less than K, so in the case, in the case less than a number K, the syntax in the table says that that third value should be K minus 1. So if K is 5, 5 minus 1 is indeed 4. So that's how you can get the 4, or you can just remember that we end at 4. So I'm not going to keep scrolling up and down here, but I just did this case. Nope, this case, X less than a number. So there is your syntax, and that's what we just did. So less than K, that third value is K minus 1. All right, I'll type this one in, and then the others, I'll just give you the answers here and you can type it in. So go to your distributions, and we want to make sure we pick binomial CDF, and then 8.7, 4. All right, and that is 0.194. Switch back to my other color here, 0.194. And I'll just leave that in decimal. All right, let's look at the next case. Find the probability that at least 4 employees commute by car. So at least 4, at least would be greater than or equal to 4. So the probability that, so we need our random variable here, X. X needs to be at least 4, greater than or equal to 4. So I'm going to circle those possibilities. So at least 4 employees, that means that maybe 4 commute by car, or maybe 5 commute by car, or 6, or 7, or possibly 8. So in this case, the accumulation, adding those probabilities, does not start at 0. So what we do is apply the rule of complements. So we'll find the accumulation for this complement of the event using our binomial CDF, and then we'll apply here the rule of complements. All right, so the greater than or equal to case, you're going to do 1 minus, so binomial CDF, and then the N and the P don't change. There's your N and your P. And then the third value here will be the 3. And if you want to use my table to get that answer, the table above would say the case of x greater than or equal to k. We go syntax 1 minus binomial CDF NP, and then that value 3 was found with k minus 1. So 4 minus 1 gives you that 3. Okay, and actually I will type this one in with you as well. So I suggest typing it just like we wrote it, 1 minus, and then go to your binomial CDF. So on your screen, you'll have 1 minus binomial CDF, and then 8.7 and the 3. And that will be 0.942. All right, 0.942. All right, next case. Find the probability that more than 2 employees commute by car. So more than 2 would be greater than 2. Just make sure when you write the probability question, don't forget X. So X is the number of successes. We want that to be more than 2. All right, so more than 2 employees. More than 2 would start at 3. So maybe 3 employees commute by car, or 4 or 5 or 6 or 7 or 8. So that's more than 2. And again, I'm going to use the rule of complements. And the complement would end here at 2. So the complement rule, 1 minus, and then we'll do binomial CDF, and then N and P. And then I know that third value should be 2. And if you use the table for help, anytime you have X greater than a number, K, the syntax is 1 minus binomial CDF, and then there's NP, and now that third value is the value of K. All right, and type that one in, and you are welcome to check, but that should give you 0.989. So notice that that answer is a little bigger than that one because there are the values 4 through 8 circled there. And this one, we also include the probability of 3. So that makes sense. This probability is larger. Okay, so we've got our less than case. We have our at least case, and then there's more than, and then let's do at most. Find the probability that at most 5 employees commute by car. So at most is less than or equal to. So at most means at the max. So the probability that X is less than or equal to 5 employees. All right, so less than or equal to 5 would include 5 employees, or maybe 4 employees, or 3, or 2, or 1, or 0. And because that accumulation of probabilities would start at 0, we don't need the 1 minus. The syntax would be going straight to our binomial CDF, NP, and then I know 5 goes next because I know I end at 5. But if you want to check the table for help, it says when you have X less than or equal to K, so less than or equal to K, that third value is the value K. And then you can type that one in and check. That will be 0.448. Okay, so make sure you're good with the various cases, and if it helps, you can reference that table that shows you the syntax for each of those cases. So remember, binomial PDF was for the equality case, and then we just covered in this one the 4 different inequalities. All right, hopefully that helps.